This is the first video on section 6.6 Lagrange multipliers. And here I'm going to talk about theorem 190 and definition 191 at the same time and sort of introduce the problem or the type of problems that we're trying to solve with this. So what we have is we have these two functions from Rn into R. F is the function we want to find the local extrema of. So we want to find a local max or a local min of f at c, subject to the constraint g of x is equal to 0. And so that's the problem that we're setting up. Now in the theorem, we're making some assumptions about f and g. For example, they have continuous first order partial derivatives. And we're assuming that f has our local extrema at c, subject to the constraint g of x equal to 0. We're also assuming that the gradient of g at c is not the 0 vector. Then there is this number lambda, such that the gradient of f at c is equal to lambda times the gradient of g at c. This lambda is called the Lagrange multiplier. So this is another type of problem where we're going to try to find a max or a min of f under certain conditions. Now, like all of our other procedures in the past, since we know something about the function at the point where those extrema occur, then we look for those occurrences, and that's where we look for our extrema. Okay? So for example, in Calculus 1 we found the critical points. In Calculus 3 we find the critical points and we perform the second partials test. What we're going to do here is we're going to look for lambda. We're going to look for Lagrange multipliers, and we're going to use those to find the max and min of f subject to these constraints.